Namaste, my dear Java enthusiasts. Welcome back to the channel. Today, we are diving deep into a truly powerful feature of Spring Framework, Spring Async, and the magical @async annotation. In modern applications, responsiveness and performance are absolutely crucial. We cannot afford to have our users waiting while our application performs long-running tasks. That's where asynchronous processing comes into play, allowing your application to perform multiple tasks concurrently without blocking the main thread. By the end of this 5-minute tutorial, you will understand what asynchronous processing is, how to effectively use the @async annotation in your Spring applications, and how to handle its nuances like a true professional. Get ready to supercharge your Java applications and make them incredibly efficient. Let's begin our journey. Alright, let's first understand why asynchronous processing is so vital. Imagine you are at a coffee shop. In a synchronous world, you order your coffee, and you stand there, waiting patiently until your coffee is ready before you can do anything else. If the barista is busy, you wait even longer. This is how many traditional applications work. One task completes fully before the next one can even start. Now, in an asynchronous world, you order your coffee, and while the barista prepares it, you can go find a table, check your emails, or even order a pastry. You are not blocked. You get a notification when your coffee is ready. In Java, this translates to long-running operations like database calls, external application programming interface requests, or complex calculations. If these tasks run synchronously, they block your main application thread, making your application slow and unresponsive. Asynchronous processing allows these tasks to run in separate threads, freeing up your main thread to handle other requests immediately. This significantly improves user experience and application throughput. Now, how do we achieve this magic in Spring? Enter the @async annotation. To enable asynchronous processing in your Spring application, you first need to add the @enableAsync annotation to one of your Spring configuration classes. This tells Spring to look for methods annotated with @async and execute them in a separate thread pool. When you annotate a method with @async, Spring intercepts the method call and executes it using a task executor, typically a thread pool, instead of the calling thread. This means the calling thread does not wait for the @async method to complete, it simply continues its execution. Think of it as delegating a task to a dedicated worker. The worker performs the task in the background, and your main thread can move on to serve other requests or perform other operations. It's a powerful way to offload work and keep your application responsive. Let's look at a practical example of how to use @async and, importantly, how to get results back from an asynchronous operation. While @async methods can return void, often you need to retrieve a result from the background task. For this, we use java.util.concurrent.future or, more commonly, java.util.concurrent.completable-future. Here, we have a service method calculate.async annotated with @async, which simulates a long calculation and returns a completable future of type string. When another service calls calculate.async, the main thread immediately continues. It doesn't wait for the calculation to finish. Later, when the main thread needs the result, it calls futureResult.get. This call will block only if the result is not yet available. This pattern is incredibly useful for operations where you can perform other work while waiting for a computationally intensive task to complete, maximizing your application's efficiency and responsiveness. While @async is incredibly powerful, there are a few common pitfalls you should be aware of. First, self-invocation is a frequent mistake. If you call an @async method from another method within the same class, the @async annotation will not work. This is because Spring uses proxy-based aspect-oriented programming for @async and the proxy is bypassed during internal calls. The solution is to call the @async method from a different Spring-managed bean. Second, forgetting to add @enableAsync to a configuration class is a common oversight. Without it, @async annotations will simply be ignored. Third, always consider how you will handle exceptions in asynchronous methods. By default, exceptions are swallowed. You might need to implement a custom async exception handler to log or handle them properly. Finally, always use future or completable future if your asynchronous method needs to return a value, otherwise, the result will be lost. And that brings us to the end of our deep dive into Spring Async and the @async annotation. We've covered why asynchronous processing is essential for modern, high-performance applications, how to enable it with @enableAsync, and how to use the @async annotation to run methods in separate threads. We also explored how to retrieve results using completable future and discussed crucial common mistakes to avoid, such as self-invocation and proper exception handling. Remember, mastering asynchronous programming is a key skill for building scalable and responsive Java applications. Keep practicing these concepts, experiment with different scenarios, and you'll soon be writing highly efficient code. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and don't forget to subscribe to the channel for more advanced Java programming tips. Keep coding, keep learning, and I'll see you in the next video. Jai Hind.